Want to add a new tool? Just add one handler. The loop doesn't need to change at all. Just register the new tool in the dispatch map. Last lesson, we built a minimal agent with only a shell tool. But think about it. Making the AI read files with shell commands, write files with string substitution, and crash on special characters. That's like using a hammer as a screwdriver. It works, sort of, but it's awkward. Today, we're adding compartments to our toolbox. Each tool gets its own slot, its own safety boundary. And the loop itself? Doesn't change by a single line. Let's talk about the problem first. With only the shell, every operation goes through the terminal. Read a file? Run a command. But the output might get truncated unpredictably, and for large files you might only see half of it. Write a file? Use string replacement, but special characters can make it crash. And the security angle is even worse. Every shell call is an unconstrained security surface. A destructive command won't stop you. It's like giving an intern root access and saying figure it out yourself. Sure, they can get work done, but you'll be sweating the whole time. We need dedicated tools, each with path sandboxing built in, keeping the dangerous stuff locked away. Here comes the solution. Look at this diagram. The user sends a message to the model decides which tool to use, and looks it up in a dictionary, a tool handler dictionary. Shell maps to the shell handler, read file maps to the read handler, write file maps to the write handler, edit file maps to the edit handler. Look it up, call it, and feed the result back. That dictionary is the dispatch map, a mapping from tool names to handler functions. Want to add a new tool? Just add one registration. It's like adding compartments to a toolbox. Wrenches go here, screwdrivers go there. Every tool has its own place. The entire dispatch logic is one dictionary lookup. No more chains of conditional checks. Let's look at the code. First up, the path safety function. What it does is simple. It resolves relative paths to absolute paths, then checks whether the resulting path is still inside the working directory. If someone tries to use // to escape the workspace, it throws an exception. That's your path sandbox. Now look at the dispatch dictionary. One dictionary, where the key is the tool name and the value is the corresponding handler function. It uses a lambda to unpack the arguments and pass them in. How does the loop use it? Just one line. Look up the tool name in the dispatch dictionary to find the handler, then call it. If you get back nothing, it means an unknown tool was encountered, so return an error message. It's that simple. Key takeaway. What's the most important insight from this lesson? The loop never changes. From lesson 1 to lesson 2, we added 3 new tools, we added the dispatch map, we added path sandboxing. But the agent loop function? Open the code and look. It's identical to lesson 1. Infinite loop, call the model, check for tool calls, execute the tool, feed the result back. Not a single line changed. What does this tell us? Good architecture means adding new capabilities without touching the core loop. Tools are plugins. The loop is the engine. The engine stays put. Add all the plugins you want. Let's do a side-by-side comparison. In lesson 1, we had 1 shell tool, hard-coded dispatch, and 0 security. By lesson 2, we have 4 dedicated tools, dictionary-based dispatch, and path sandboxing. But the loop? Still unchanged. From 1 tool to 4, the codebase grew, but the core architecture got cleaner. It's like going from a single Swiss Army knife to a proper toolbox. More tools is fine. The dictionary handles it all.